Good morning students. Today I came back with a new topic, chapter number 14, equation of a line. Student, we will discuss about equation of a line. In previous class 9, we already drawn the line of this type of equation, ax plus by equal to c, and this is a linear equation. This is a linear equation, and students, we can represent a line only by a linear equation. Either this is in a x or y variable, two variable, yeah, or only in a x variable or only in a y variable. Clear students? Now we discuss same process equation of a line, and equation of a line we represent by a linear equation. Clear? There are two main points in this first exercise. First point, any point which satisfies the equation of a line lies on that line. That means any point which satisfies the equation of a line, any point satisfy this type of equation, then that point lie on that line. For example, if there is a line and any point lie on this line, then this point satisfy the equation of this line, this line. Clear student? And second point, any point through which a line passes through will satisfy the equation of that line. Any point through which a line passes, if there is any point and a line passes through this point, then this point also satisfy the equation of this line. Clear student? Now we have some example for solving this type of question. Now we have first question. There is an equation of a line x minus 2y plus 5 equal to 0. And which of the point satisfy this equation? Which of the points satisfy this equation? Student, if this point satisfy this equation, then left hand side and right hand side both are equal. Now first we check this point. We have an equation x minus 2y plus 5 equal to 0 and a point 1, 3, x coordinate 1 and y coordinate 3. Then we put in this equation in place of x equal to 1 and in place of y equal to 3. Clear? Then put in place of x 1 minus 2 into y plus 5. 1 minus 3 multiply 2, 6 plus 5. 1 plus 5, 6 minus 6. 6 minus 6 equal to 0. Then left hand side equal to right hand side. Then 1 and 3, this point lie in that line. Clear student? Again same, we check this point lie in this line or no. Next same, we have an equation 2y plus 5 equal to 0 and a point minus 5 and 0. First we put a x equal to minus 5 and y equal to 0. Left hand side in place of x minus 5 minus 2 into in place of y 0 plus 5 minus 5, 2 multiply 0 minus 0 plus 5. 5 minus 5, 0. Then left hand side equal to right hand side. This point also satisfy the equation of a line. Then this point also lie in that line. Clear student? Next we have next question number 2. The line x by 2 plus y by 3 equal to 0 passes through the point 4 minus 6. True or false? This is the question of true and false. There is a line and it said point 4 minus 6 lie on that line. This line passing through this point, then this point also satisfy the equation of line. This is true or false? First we put in place of x equal to 4 and in place of y minus 6 x in place of x 4 by 2 plus y minus 6 by 3. 4 by 2 2 plus minus 6 by 3 minus 2. 2 plus minus 2 2 minus 2, then this equal to 0. This point satisfy the equation of this line. Then this point lie on that line and this line passing through this point. So it is true. Clear, student? Then we take a next question. Passes through the point K6. Calculate the value of K. This line passing through this point. If this line passing through this point, then this point satisfy the equation of and this line. Clear, student? And if we find out the value of unknown and K, we have an equation 2x minus 5 by 3 equal to 7, and this line passing through the point K6, then this point satisfy the equation of this line. Means lie in this line, the left hand side equal to right hand side. In place of x we put k, and in place of y we put 6. In place of x 2 into k minus in place of y 6 by 3 equal to 7. This point lie in this equation, so left hand side equal to right hand side. 2k minus 2 equal to 7. 2k equal to 7 plus 2. 2k equal to 7 plus 2 9. Then k equal to 9 by 2. Then value of k equal to 9 by 2. If any line passing through the given point, then given point satisfy the equation of that line. Then left hand side equal to right hand side, we find the value of unknown. Clear, student? The next question, question number 5. The line this contains the point m to m minus 1. Calculate the value of m. Same as it is. The line contains the point. That means a line contains a point this and coordinate of this m to m minus 1. Find the value of unknown m. Same as it is. If this line contains this point, then this point satisfy the equation of this line. So in place of x we put m, and in place of y we put 2m minus 1. So 3 into, in place of x, m divided by 5 minus 2 into y, in place of y 2m minus 1 divided by 3 plus 1 equal to 0. We take left hand side equal to right hand side because this point satisfy the equation of this line. Clear? Then by taking LCM 15, then 9m minus 5 to 10 into 2m minus 1 plus 15 equal to 0. 9m minus 20m plus minus plus 10 plus 15 equal to 0. Clear, student? Then 9m minus 20m minus 11m plus 25 equal to 0. Then 11m equal to 25 and m equal to 25 by 11. This is the value of n. Clear? Again, next question, question number 7. The line y equal to 3x minus 2 bisect the join of a3 and 2 minus 5. Find the value of a. If this line bisected the join of these 2 points and join of these 2 points, let a point A and a point B, coordinate of A, A3, coordinate of B, 2 minus 5. Join of this line, this is a line segment, and let this line bisect the join of this, means this line segment, this line bisect this line segment. If this line bisect this line segment, then these 2 parts are same. Let this point P, AP equal to BP, because this line bisect it. Bisect it means divide into two equal parts. Then AP equal to BP. If these two parts are equal, then P is the midpoint of AB. If P is the midpoint of AB, then we find the coordinate of midpoint. So first we find out coordinate of P. Student, according to midpoint formula, what is the midpoint formula? X1 plus X2 divided by 2 and Y1 plus Y2 divided by 2. Say, we find out the coordinate of P. A plus 2, this is A. A plus 2 divided by 2 and Y1 plus Y2, 3 minus 5. 3 minus 5 by 2. Again coordinate of P. A plus 2 by 2 and minus 2 by 2 and minus 2 by 2 minus 1. Coordinate of point P. These are the coordinate of point P. Clear, student? And the equation of this line. This is the equation of this line. Again, point P is the midpoint of AB. And also point P lie on this line. Point P also lie in this line. Then point P satisfy the equation of this line. Again we take point P satisfy the equation of this line. Y equal to 3x minus 2, 3x minus 2 and coordinate of P in place of x, this and in place of y minus 1. We put in place of y minus 1, 3 into in place of x, a plus 2 by 2 minus 2. Clear, student? Minus 1, then 3a plus 6a by 2 minus 2. Minus 2 on left side, then minus 1 plus 2. 1 equal to 3a plus 6 by 2. Cross multiplication, 2 equal to 3a plus 6 and 3a equal to 2 minus 6. 3a equal to minus 4. Then value of a minus 4 by 3. Clear, student? This is the value of unknown a. Find the value of a, then value of a equal to minus 4 by 3. Clear? The next question, question number 12 of exercise 14.1. Show that the line 2x plus 5 equal to 1, x minus 3y equal to 6 and x plus 5y plus 2 equal to 0 are congruent. Students, we have to show that these three lines are congruent. These three lines are congruent if let first line A, then second line B and any line C. There are three lines. If these three lines are congruent, then they intersect each other at one point. If three or more lines are congruent, then they intersect each other at one point. So, same as it is, if these three lines are congruent, then they intersect at one point. Student, for this question, first we have to find out one point of two lines. Intersecting point of two lines. First we have to find out intersecting point of two lines. If this intersecting point find out and any third line passing this type, then this point lie on the third line. If this point lie on the third line, then first we find out intersecting point of two lines. Let first we take first equation, 2x plus 5y equal to 1 and second equation, x minus 3y equal to 6. First we have to solve two equations and find out the value of x and y. For this, first we make the coefficient of x equal. For this, we multiply equation first and equation second. We multiply equation number second by 2. Then first equation 2x plus 5y equal to 1 and 2x minus 6y equal to 12. Adding first and second equation. Subtract first and second equation. Then minus plus minus. Minus plus 5 plus 6y. Then total 11y. 1 minus 12. Then minus 11 and y equal to minus 1. We have find out the value of y. Again put the value of y either equation 1 or equation 2. We put the value of y in equation number first. 2x plus 5 into minus 1 equal to 1. 2x minus 5 equal to 1 and 2x equal to 6, x equal to 3. Value of x equal to 3. Then there is a point 3 and minus 1. From these two lines we find out the intersecting point 3 minus 1. If this point lie on the third line, then these three lines are congruent. So we have third line x plus 5y plus 2 equal to 0. If this point satisfy this equation, then three lines are congruent. So in place of x you put 3 plus 5 into in place of y you put minus 1 plus 2. 3 minus 5 plus 2. 3 plus 2, 5 minus 5 equal to 0. Left hand side equal to right hand side. So point 3 minus 1 satisfies the third equation. So these three lines are congruent. Clear student? Student, for next exercise, first we have explained some basic concept. First, inclination of a line. Inclination of a line means theta, angle. We find out the inclination of a line means theta. If there is a x-axis and a y-axis, x-axis and a y-axis, any line make an angle with the x-axis. For example, x-axis, y-axis, and any line. This line make an angle with the x-axis. Make an angle with the x-axis equal to theta. This is the inclination of a line. Inclination of a line is the angle a line make with the x-axis and above the x-axis. And student, we measure the theta in two types, anti-clockwise or clockwise direction. If we take in a anti-clockwise direction, means this direction, this is the anti-clockwise direction, then theta positive, and if we take anti-clockwise direction, then theta is negative. For example, if this is equal to x-axis and this is a y-axis and this is a line make an angle with x-axis, this is a clockwise direction, then theta is negative, and we take if a clockwise direction, then theta is positive. Clear student? We measure theta into types, clockwise or anti-clockwise. In anti-clockwise, then theta is positive, and if we take a clockwise, then theta is negative. Clear? Again, there is a concept slope of a line. Slope of a line. What is the slope? If x-axis and y-axis, this is a vertical distance and this is a horizontal distance, and any line, this is a line, and line make an angle with a x-axis, then this is the slope of a line. If we find the slope of a line, slope equal to vertical distance divided by horizontal distance. For example, A, B, C. Then vertical distance AB and horizontal distance BC. then the ratio between vertical and horizontal distance is the slope of a line. And student, in trigonometry we measure this type. In trigonometry this is a perpendicular, this is a base, perpendicular by base is the tangent theta. So we take a tangent theta equal to AB by BC. This is a tangent. Clear student? This is the slope, and we represent slope by a small letter m, and we take m equal to tangent theta. Tangent theta is the angle a line make with the x-axis. Clear student? Again, if theta is given, then we find out the slope of the line by tangent theta. Again, if a line passing through two given points, like a point A, coordinate of A x1 y1, and a point B, coordinate of B x2 y2. If a line passing through given 2 points, then again we find the slope of that line by 2 point form. By 2 point form, slope of AB equal to, if 2 point given, then slope of AB equal to y2 minus y1 by x2 minus x1. Student, if we have an angle theta, then we find slope by tangent theta. If we have two given points, then we find the slope of that line by this line. Clear student? This is a slope concept. Clear? If x-axis and a y-axis, if a line on the x-axis, then theta equal to 0. Theta equal to 0, and any line parallel to x-axis, any line parallel to x-axis, then theta also equal to 0. Because if this is x-axis, this is a line, then line make an angle with x-axis 0 degree, because form an angle, two lines intersect each other, then we find an angle. If two lines are not intersect each other, then there is no angle. So theta equal to 0. And if x-axis and y-axis, and any line on y-axis, and y-axis make an angle with x-axis 90 degree. So any line on the y-axis, then theta equal to 90 degree, and any line parallel to y-axis, then also theta equal to 90 degree. Then slope of x-axis equal to tangent 0, because x-axis angle 0, then tangent 0 equal to 0, and slope of y-axis, a line make with a y-axis 90 degree, then tangent 90 degree, this equal to infinitive, means not defined. Clear student? Slope of x-axis and any line parallel to x-axis, then slope of that line equal to 0, and any slope of y-axis or any line parallel to y-axis, then slope of that line equal to tangent 90, infinitive, means not defined. Clear student? Next slope of parallel lines. Slope of parallel lines and slope of perpendicular lines. Students, slope of parallel lines. If two lines are parallel, L1 parallel to L2, then slope of L1, if we take slope of L1, M1, and slope of line L2, M2, then both the slope are equal. If two lines are parallel, then their slope equal. If slope equal, then line parallel. If line parallel, then their slope equal. Student, this is conversely. Say again, slope of perpendicular line. If we have a line L1 perpendicular to the line L2 and slope of line L1 M1, slope of line L2 M2. If these two lines are perpendicular, then there is a condition slope of these two line product of slope equal to minus 1. Student, if two lines are parallel, then their slope equal. If two lines are perpendicular, then product of their slope equal to minus 1. This is the condition for parallel and for a perpendicular lines. Again, collinearity. Collinearity of 3 points. Collinearity. Collinear of 3 points. Collinearity. Student, collinearity. If 3 points are collinear, 2 or more points are collinear. Student, if 2 or more points lie on the same line, then these points are collinear. Let point A, point B and point C. We have to show that point A, B, C are collinear. Student, point A, B, C are collinear. A, B, C are collinear if there is a condition slope of AB. Slope of AB equal to slope of BC, then these 3 points are collinear. Same, if slope of AB equal to slope of BC, then these 3 points are collinear. If 3 points are collinear, then slope of AB equal to slope of BC. Clear, student? Now we take some questions of exercise 14.2. Then for exercise 14.2, question number first. Find slope if there are theta given. Theta equal to 0 degree, theta equal to 30 degree and theta equal to 72 degree 30 degree. Clear? First we take theta equal to 0 degree. We find out the slope. Slope denoted by small m, and this equal to tangent theta, and tangent theta in place of theta tangent 0 degree, and we know that tangent 0 equal to 0, then slope equal to 0. Clear, student? If theta equal to 30 degree, then slope m equal to tangent theta, and in place of theta tangent 30 degree, and we know that tangent 30 1 by root 3, then slope 1 by root 3. Clear, student? If we take theta 72 degree 30 minute, then m equal to tangent theta in place of theta 72 degree 30 minute. For this question, student, you use a trigonometrical table. Use a trigonometrical table. Tangent 72 degree 30 minute. You find the value of this, then slope m equal to this. Clear? This is the first type of question. If angle given, then we find out a theta. Student, in second type of question, if slope is given, in first type theta is given, we find out slope, and in second type of question, slope is given, we find out theta. In first question, slope equal to 0. If slope equal to 0, slope denoted by m, and m equal to tangent theta, and m equal to given 0, tangent 0. Student, tangent take value 0 on a 0 degree, then we write this tangent 0 degree, then theta equal to 0 degree. We find out theta. Again, then if slope equal to root 3, slope denoted by small m, and slope equal to tangent theta, and slope given equal to root 3, m equal to root 3, tangent take value root 3 on a 60 degree, then tangent theta equal to tangent 60 degree, then theta equal to 60 degree. With the help of a trigonometric table, we find out theta. Clear, student? Again, question number third. point this and point this. There are 2 points of a line. A line passing through these 2 points, find a slope. If there are 2 points, we find out slope by 2 points of 4. If 2 points are given, let this point x1, y1, this point x2, y2. Then according to 2 points given, slope या m. Slope of line m equal to y2 minus y1 divided by x2 minus x1. Same, slope m equal to y2 minus y1, 2 minus 3, 2 minus 3 by x2, 1 minus 2. Then 2 plus 3 by 1 plus 2, 5 by 3. Then slope of that line passing through these 2 points, slope is 5 by 3. Clear? The next question, find the slope if a line parallel to AB, if A coordinate of A and coordinate of B. There is a line AB, coordinate of A minus 2, 4, coordinate of B 0, 6. Any other line, let a line, this line parallel to AB, then we find the slope of this line. First we find the slope of AB, then if 2 lines are parallel, then their slope are equal. So first we find the slope of AB. Slope of AB. If slope of AB and there are 2 points, so we use 2 point form. Then 6 minus 4, 0 plus 2, 6 minus 4, 2 by 2 and this equal to 1. Slope of AB equal to 1. Let slope of required line M, then M also equal to 1 because these 2 lines are parallel. If 2 lines are parallel, then their slope are equal. Clear? Next, question number 5. Find slope of a line perpendicular to line AB if coordinate of A and B are given. If 2 lines, line L1, line L2, 2 lines are perpendicular. If 2 lines are perpendicular, then product of their slope equal to minus 1. We find the slope of a line if that line is perpendicular to AB. First we find out the slope of AB. Slope of AB same as it is by 2 point AB by 2 point form. y2 minus y1, 2 minus plus 2, x2 minus x1, x2 minus 1 minus 3, then 4 by minus 4 equal to minus 1. Students, slope of line AB equal to minus 1 and a line perpendicular to AB, then slope of that line, let slope of that line M1 and slope of line AB M2 equal to minus 1, then M1 cross M2 equal to minus 1, M1 as it is, M2 in place of M2 minus 1 equal to minus 1 and M1 equal to minus 1 by minus 1 equal to 1. Then slope M1 equal to 1. Student, if 2 lines are perpendicular, then product of their slope equal to minus 1. If we find out M1, then we use minus 1 by M2, and if we find out M2, then we can use minus 1 by M. Clear? The next question, question number 7. The line passing through this and this point is perpendicular to the line passing through these two. Find the value of A. Student, the line passing through these 2 points, a line passing through these 2 points perpendicular to the line passing through these 2 points. There are 2 lines. First line passing this point, second point passing these 2 points. find the value of A, and both lines are perpendicular. First, we find out slope of first line. Slope of first line. Slope of first line same as it is y2 minus y1 divided by x2 minus x1. y2 minus y1 x2 minus x1 equal to minus 1 by 4. Again, slope of second line. Slope of second line, and second line x in place of x1 minus 4, then x2 x1 x1 y1 x2 y2, then y2 minus y1 then plus 2, and x2 minus x1, 2 minus minus plus 4, then minus 1 by 6. Clear? Again, slope of second line. Second line passing through these 2 points. Second line passing through these 2 points, then we find the slope of second line. y2 minus y1 minus 1 minus 5 by x2 2 minus a minus 6 by 2 minus a. This is the slope of first line. This is the slope of second line. And these 2 lines are perpendicular. Student, if 2 lines are perpendicular, then product of their slope equal to minus 1. So, slope first minus 1 by 6. Slope of second line minus 6 by 2 minus a equal to minus 1. Minus minus plus 6 by 6 into 2 minus a equal to minus 1. 6 by 6 cancel. Then cross multiplication. 1 equal to minus 2 plus a, then 1 plus 2 equal to a, then value of a equal to 3. Student, if there are 2 lines parallel, then their slope equal. If 2 lines perpendicular, then product of their slope equal to minus 1. You use these 2 concepts in your exercise. Clear? So, do this exercise 14.1 and 14.2. Okay, thank you.